Thank you for coming out for the first lecture in the 6th year of the Hirman Lecture Series, a lecture series that is dedicated to addressing those topics that are important to ensuring a sustainable supply of food, natural resources for the world, and for ensuring the sustainability of the rural communities that produce that food and that fuel and the energy. We have with us today Keith Hirman, who has made this lecture series possible. Stand up and take a bow, Keith. It's through the generosity of Keith and his wife Norma that we can make this lecture series possible. As I said, it is the 6th year of the series, and we have had many interesting speakers stand at this podium, and I think we have a very interesting one today, although I'm not sure whether he's going to stay close to the podium most of the time, but I think you will be genuinely interested in what Mark Lynas has to say. The lecture is being streamed online, so as we approach the time for questions and answers, if you're online and you have a question, send your questions to #HLSeries. That's #HLSeries. Mark will make his presentation, and then when he finishes, we'll have plenty of time for your questions, and I hope you will have questions for him. We will have people in the aisles with a microphone, so if you're in the audience and you want to ask a question, please come to one of the aisles and use one of the microphones to ask your question. We've tried for a number of years to have Mark come and be a presenter in this lecture series, and finally this year we've been able to make the schedules align and have him come. He talks about the importance of science in addressing those controversial issues that are facing our society, our global society today. And I think it will be very interesting to hear what he has to say about the use of GMOs, because a number of years ago, in 2013, he publicly reversed his stance on GMOs. Prior to that time, he was relatively active in opposing the use of GMOs, and after looking at the science, he changed his mind and has come out with reasons why we should embrace GMOs and the positive effects that GMOs can have in the world. The society that he comes from, we talked about this at lunch, he comes from Britain, and he has been active there in the area of being an advocate for science. And we've talked about, at lunch we had a conversation about how important critical thinking is to addressing those issues that we have facts that we can use to address. So he's traveled the world, he's here with us this afternoon, and Mark, come on up and give us your thoughts about, I almost said about whatever you're interested in giving us your thoughts about, but that wouldn't be a problem. So give us your thoughts about science.
Well, thanks for that very generous introduction, Ron, and apologies for the spoiler. You now know what I'm going to talk about, and I hope I can do some justice to the theme. It's great to be here at the University of Nebraska, a land-grant university, obviously, and a lot of you will have a big interest in farming, in feeding the world, and in producing crops. Now, I used to not produce crops, I used to destroy them. I used to destroy them because I believed that there was something fundamentally unnatural, something inescapably evil almost about the technology of genetic modification. So starting from the mid-1990s, for the half-decade thereafter, I was out in the fields with my colleagues in the environmental movement, personally attacking and destroying multiple different types of genetically engineered crops. We went out into the maize fields in the east of England under the cover of darkness, and with our machetes we chopped through these rows of corn, healthy green plants which are taller than I was at the time. I also destroyed genetically modified sugar beet, potato, oilseed rape, and other things which it was too dark to identify at the time. It was perhaps the most successful environmental campaign I've ever been involved in. We succeeded not only in decontaminating those particular fields that we targeted for vandalism, but we also succeeded in undermining the entire public support for biotechnology. And we succeeded in ushering in a prohibitionary regime which continues to this day, not just in the United Kingdom, but in Europe and in many other countries besides. Now, I do claim the credit for having not only written the first anti-GMO piece in the environmentalist literature in the UK, but also for starting the first anti-Monsanto action. So I discovered that Monsanto had its headquarters not too far from where I was in Oxford, and I did a recce, and I printed out the leaflets, and we hired the buses, and we got into the building. And you know how we got into the building? Even though they had a security code and other protective mechanisms, we got into the building because, this being England and everyone being polite, someone held the door open. And we said, "Thank you very much," and in we went. And we had some actions which were slightly less successful. Did you ever hear about Dolly the Sheep, the world's first cloned farm animal? So we came up with a plan to steal Dolly the Sheep. This was in about 1999. And so we went up to the Roslin Institute, which is up in Scotland, on the chillier part of the British Isles, and we spent a day having a look around. I was posing as a researcher, and the Roslin Institute kindly gave me access to the library. So I toured the corridors and eventually found out which shed I believed that Dolly was being kept in. And one of my colleagues posed as an American tourist, so with a big camera, as Americans do tour the world like that, and she had a look from the outside. Comes the cover of nightfall. We were under a bush, freezing our toes off, till about 3 o'clock in the morning when we decided it was time to swoop. So we got to the shed with Dolly in it, and would you believe it was full of sheep, and they all looked the same. And of course, a clone sheep looks even more the same by definition. So we weren't able to steal Dolly because the scientists rather cleverly had hidden her in plain sight. You can actually find Dolly now in the stuffed and mounted in the National Museum of Edinburgh, and if you go and visit her, you'll get closer than we ever managed to. But notwithstanding that failure, as I say, our campaign was successful, not just in Europe, but we managed to export our fears about GMOs to many countries around the developing world, India, Africa, elsewhere in Asia too. But around this time, I began to get interested in a different subject, namely climate change. Now, this was back in about 1999, 2000, when the awareness of climate change wasn't as ubiquitous as it perhaps is today. And what I wanted to do, because this was mainly an issue which was talked about in scientific terms with graphs and data, I wanted to try and humanize it. I wanted to give a sense that not only was climate change real, but that it was having human impacts, to try and put an emotional storyline behind what had previously been presented only as a very rational scientific issue. So I decided to do a travelogue, and I wanted to tour the world, experiencing directly at first hand and interacting with people who were themselves experiencing the first impacts of global warming. One of the places I visited was Alaska, where indigenous people who, Inupiat Eskimos, who depend very much for their subsistence lifestyles on the sea ice, have been finding that the ice is either forming later or disappearing earlier in the year, and that's undermining their livelihoods and in some ways, in some cases, undermining the actual physical realities that they live in. Their villages are being eroded because the sea ice is not there, and the sea is therefore undermining the coast. I also visited the Pacific island nation of Tuvalu, which is on average above sea level, only about as high as this, actually slightly lower than this lectern is above the floor, literally about 1 meter above sea level. That's the average height, and the highest point in the whole of the island is about 3 meters above sea level, and it's a big ridge of rubble which was piled up there by a hurricane. Not very reassuring. And people are very aware of the fragility, the physical fragility of their situation. And especially the more so when during the high tide seasons, the water actually comes up through the floor in their houses and around the outside, because the sea levels are rising, not just there, of course. This is a phenomenon which is observed globally. And perhaps most striking of all to me, I went back to Peru, where I spent 3 years as a kid, when my father was working as a geologist in the high Andes in the Cordillera Blanca. And I went back to one of the remoter regions where he had photos of how the glaciers looked when he was there in 1980. And when I returned in 2002, in just a single generation of my own family, these whole glaciers, these monumental rivers of ice had disappeared. And I knew that this was important for the population of Peru because these are the reservoirs, if you like. These are the water supplies, the fresh water supplies that the coastal population, which is in a desert area, depends so much upon. And I had my closest brush with mortality, if you like, when I went from sea level up to 5,000 meters to see the glacier which supplies Lima with its water, with its fresh water. And I did that in about 5 hours and came down with such a severe dose of altitude sickness, I think it was probably a cerebral edema, that I lost all the motor control. I couldn't hold anything. And I managed to drop my stuff. I couldn't even pick it up. And what was anyone here who does outdoor pursuits or mountaineering, what's the one thing you don't ever do? Right? Go out by yourself. I was there alone, and I began to lose consciousness. And I remember the lizard brain part of me saying, this is time to get down. So I crawled down out of there. But having come back with all of these anecdotes and wanting to present them into a compelling picture of what the reality of global warming, I knew that I had to back this up with science. That data is not the plural of anecdote. That there had to be something, there had to be an evidence base which is more compelling and more profound than what I could just see with my own eyes. And so, and I'm a politics and history graduate, by the way. I don't have any formal scientific training. So I had to learn about glaciology, and I had to look at the data. I had to look at the empirical evidence which is published in the peer-reviewed literature, not just about glaciers, but about sea level rise, about deforestation, about the physics of greenhouse gases, and all of the other multiple lines of evidence which draw us to the inescapable conclusion that this problem is both real and increasingly at a critical juncture. And I published that book in 2004, and it was called High Tide. And then I moved on later to an even more sciencey book, which later was published in 2007, called 6 Degrees. And I wanted to put together a degree-by-degree map of how the planet could change as global warming accelerates. And interestingly, Nebraska was one of my chosen locations for the first chapter, I believe it was, because there's an area called the Sandhills, I'm sure you know it, which was a fully mobile, hyper-arid desert back in the early Holocene, when the temperatures was about a degree or so warmer than it is today. So it isn't too far of a supposition, and this is one aspect of paleoclimate, looking at past climates which have been hotter and can be an analog for the future, which I was looking into very closely, as well as climate modeling and as well as observed temperature change. Now, when this was published in 2007, I found myself involved with a lot of controversy. The American edition was published by National Geographic Books, and they also made a film out of it, which was broadcast coast to coast, as you say here, and voiced by some guy called Alec Baldwin, who I'd never heard of, but apparently he's a famous Hollywood whatever. But I did a sort of radio tour of duty for National Geographic, where I sat in and I talked to callers from different radio stations around the country, and so many of them were saying to me that they simply didn't believe it, and that pretty much nothing I could say would make them believe it. And I said to them, but I've looked at hundreds of peer-reviewed papers, probably thousands through dozens of the most prestigious academic journals, and of course this cut no ice with any of them, because this had become, by that point, an incredibly polarized and in controversy-laden debate. But as I said, at that time I was beginning to align myself more with the scientific community. I wanted the scientists to appreciate my work, because what I was doing as a communicator and as a science journalist was essentially to translate between the very academic, jargon-laden language that the scientists were writing in their papers, and translate that across to a popular audience. But I needed to make sure I got the science right, and I needed to make sure that I was honestly reflecting the majority opinion of the expert scientific community. And so I was delighted to be honored with the 2008 Science Books Prize presented by the Royal Society in the UK, and the Royal Society being the most prestigious scientific organization, in June 2008. Now, why is this date relevant? Because 2 days after I received that prize, giving me, as I saw it, the stamp of approval from the most prestigious scientific body in the UK, I wrote my last anti-GMO article in The Guardian, which had no references, no basis in the peer-reviewed literature, no academic standing whatsoever, and just made the same kind of rhetorical assertions as I had already been making together with other anti-GMO activists for more than a decade. Now, I didn't think that when I was writing it. The Guardian called me and said, can you write us an anti-GMO piece? And I said, yeah, I can do that. It only take 20 minutes. And I dashed it off. And it wasn't until I went below the line and I read some of the comments, and people were saying things like, this is your witchcraft. You have no support from the scientific community. And that stung me, because I considered myself aligned with the scientific community on the climate issue, and I'd worked very hard to achieve that kind of credibility. And so I really began to think at that point. This was in 2008. And so rather than immediately talking about it and making a big scene, I took some time out to read up on the subject, because I realized I lacked the very basics of biology training. Whereas I'd spent years reading the peer-reviewed literature on everything from glaciology to geophysics, I had no molecular biology, no biochemistry, I had no knowledge at all. And when I was an anti-GMO activist, I didn't read or appreciate a single peer-reviewed paper on the subject. And so I began to write a book in 2011 which later became called The God Species, about this idea of a new scientific idea of planetary boundaries, that there are aspects to the Earth system which, if we interfere with them too profoundly, could tip us over the boundary into an unsafe space, if you like. And climate change was a clear example of that. And the boundary which was proposed was 350 parts per million of CO2 in the atmosphere. So they actually proposed numbers for some of these boundaries. And so many of these boundaries were wrapped up in one issue, which was agriculture, farming. The proposal for a nitrogen boundary, that we've interfered so profoundly with the nitrogen cycle that we've got dead zones. The most obvious example being the one that appears annually in the Gulf of Mexico. Where does that come from? Well, it comes from, by and large, runoff from the Corn Belt. Other boundaries being land use change, water use, and so on. All of these were so clearly involved with farming. And when I began writing The God Species, I thought I'd probably end up writing an anti-GMO line to it. And I looked around the literature as I had done in previous books, and I couldn't find anything which supported the anti-GMO perspective, which was a problem, because I didn't want to have to come out and change my mind publicly about this. And I also kept coming across examples in the literature of GMO techniques which could be used to actually help meet some of these boundary conditions. For example, nitrogen-efficient crops would mean that we could use less fertilizer. And wouldn't that help address the dead zone in the Gulf of Mexico? And drought-tolerant crops might mean that we could use less water, and that would mean interfering less with the river systems. Greater productivity would mean that we could use less land, which would mean plowing up less of the rainforest in order to feed the world's population. And around that same time, I came across a book by Stuart Brand, who's an old hippie, acid dropout, a good friend of mine now. And back in the 60s, in between acid trips, produced this whole Earth catalogue. Any of you who were around then, you really shouldn't remember it. Remember the thing about the 60s. But this was really a sort of a founding text for the environmental movement. And Stuart has completely changed his mind about this, and he wrote a book called Whole Earth Discipline, which I was asked to review, and the first sentence of one of the chapters says, "I dare say the environmental movement has done more damage with our opposition to genetic engineering than any other thing we've got wrong." And I read that and I thought, whoa. Because I really felt at that point that he'd got that right, that he was right about that, and that I had made this huge mistake. And so from that point on, I decided I would try to do something to begin to restitute it. If you feel if you've made a mistake and you've caused some damage in the world, you have to, if you're going to live with yourself, you have to at least make an attempt to put it right. And so the first thing I did was start working with the scientists in the Rothamsted Institute, which is a plant science institute in the east of the UK, where the scientists in 2012 were proposing to cultivate a field trial, the first GMO field trial we'd have had in the UK since the ones we destroyed 10 years earlier, with a genetically modified wheat, which, interesting idea. The idea was to be able to reduce pesticide use. The wheat would produce its own pheromone, which would act as a repellent for aphids, and aphids are a vector for certain diseases. So rather than spraying the pesticide to kill the aphids, the wheat would repel the aphids by producing this alarm pheromone, which aphids respond to. And so it worked in the laboratory, but the idea was to test it in the fields. And they had this huge fence in order to keep the vandals out, and they went ahead and they planted the crop. But what happened was the activists pledged to destroy it. And they gave a date. They said on May the 27th, I think it was, we are going to come to your field and we are going to destroy the entire thing. We're going to decontaminate it. And so I wanted to work behind the scenes with the scientists, using my experience on the anti-GMO side, to help them figure out a response strategy. And one of the things that they did was to record a video. And this video was really a first for the scientific community that I'd ever seen, because it was an emotional appeal with 4 of these scientists just sitting there talking straight into the camera, an emotional appeal to the activists not to come and destroy their experiment. And they ended up saying, when you visit us in May, please don't come in a spirit of destruction. Please come to share in our knowledge and to help us understand whether this experiment will work or not. Because as they said, if you destroy the crop, we'll never even know whether it worked. And yet you seem to think in advance of that this is a bad thing. And I'm not saying that the video itself had a transformative impact, but the scientists were prepared to do one thing which scientists very frequently are not, and that's to put a human face on this. They spoke to the media, they challenged the antis to a debate, which was not reciprocated. And when the day came, after petitions and all sorts of things, the activists had so few people in number and so little sense of public support that they were unable to destroy the crop. And there's an interesting coda to this. That was a success for the scientists at Rothamsted. They were able to go ahead with their experiment. But what's really interesting about this is that it didn't work. The alarm pheromone failed to repel aphids. So it was an experiment which came out with a negative result for their hypothesis. Isn't that great science? And the scientists at Rothamsted proudly published that in a peer-reviewed journal that their experiment had failed. And of course, that's so fascinating to me because if it had been destroyed earlier, we would never have known that that technology, in the way that they were developing it at the time, was never going to work. Now, I was kind of hiding at that period. I was wearing a cap and I didn't reveal myself entirely to my fellow colleagues who were on the activist side because many of them I knew personally. And I didn't feel that I wanted to openly experience that degree of conflict. But then I was asked, by 2013, I was asked to speak to the Oxford Farming Conference, which is this big sort of annual agricultural event that happens in my hometown in Oxford. And at that point, I felt like I had to come off the fence and I had to say something publicly. And so if you watch back on the video, I had this whole thing written down because I knew I wouldn't have the confidence to go out and say and to deliver this apology unless I had the whole thing written down in front of me in black and white with the words clearly chosen in advance. So I stood up there and I said, I apologize for destroying GM crops and for making a contribution to starting the anti-GMO movement. And then I sat down again and I thought, oh, because I knew that my life was going to change. It was like one of those, we all have them in our lives. That was a moment of kind of crossing the Rubicon. There's no way back. Once you make that step, once you do that thing, your life is going to be changed from then onwards. And indeed it was. I mean, my website crashed, this thing went viral, media started calling, and I found myself under intense pressure and very negative pressure a lot of the time from not just my former colleagues, but from the entire environmental movement. I went on a BBC interview on a show called Hard Talk. Has anyone seen that? Where they specialize in really putting you under the grill. And the presenter challenged me with saying, if you were so shallow, and I was sitting there, he said, if you were so shallow and so incompetent to have got this issue wrong, how can we trust anything you say now? And that struck me because that's actually the opposite of what you should say to somebody who wants to be a good scientist, right? If you start out with a hypothesis, in fact it's the reverse. Do you start out with a conclusion? And do you seek to defend that conclusion against all evidence to the contrary? And therefore never admit that you've ever made a mistake? Do you have to project an image of infallibility to be taken seriously? And well, in politics it appears that you do. We're got to be like the medieval popes. Because his main line of attack was that I'd change my mind. If you change your mind, you admit to being wrong. If you admit to being wrong, you're inconsistent, you can't be believed. I never understood why that was such a potent argument, but it was a potent argument, and you could tell it resonated with a lot of people who never changed their minds, or who consider that to be a very negative thing to be ashamed of. And from that point on, I decided that I could openly advocate, not the reverse of my previous position, which was anti-GMO. I wasn't going to go to be pro-GMO, I was going to be pro-science, and to say that you have to look at the totality of scientific evidence on an issue. And I was very struck when the AAAS, the American Association for the Advancement of Science, made a very clear and unambiguous statement on expressing the scientific consensus on GMO safety. And they said very clearly, the science is clear. The techniques of using molecular biology to improve crops are safe. And they used that language very clearly, which is almost the same language that they'd made in a similar statement on climate change, where they said, the science is clear, human-caused climate change is real. And so, if I was going to defend the scientific consensus on climate change against, by and large, what was the political right, I couldn't then say, you've got to listen to the 97% of the experts who believe in, who show that climate change is happening, and then you've got to ignore an equivalent scientific consensus on the safety of GMOs. Isn't that an inconsistent position? And people would say, well, you're appealing to scientific authority. And I'd say, well, maybe I am. Take all of you here today, put your hand up if you have personally measured the change in average global temperature over the last 50 years. No one ever volunteers on this one. But, okay, fine. Put your hand up if you accept that global warming is real. Okay, not everyone, but it's still a big majority. Now, how do you come to that acceptance? Because you accept the evidence that's been put forward by the expert community. And if you take the equivalent leap on the GMO issue, you'd end up to where I had to go, which was, if I was to have any integrity as a science communicator, I had to defend the position that was put forward by the scientific community itself, which is that GMOs are safe. And I also began to figure out the other political dimensions to this issue. Namely, that this is a technology which can and should have great benefits in developing countries. So there's a whole moral justice aspect to this, which previously I had not anticipated, not understood, and not appreciated. So with the support of the Bill and Melinda Gates Foundation, I went to East Africa, and I started off in Kenya, I went to Tanzania, and I also went to Uganda. And I met some of the scientists who were working on homegrown GMO solutions to some of the serious food security challenges that those countries are facing. For example, in Uganda, you can visit the banana plantations, and banana is a really critically important staple crop in really that whole region. And they have these green bananas, by the way, which they mash up and steam. It's called matoke. So it's a bit like mashed potato. It's their staple carbohydrate. And these bananas, the trees are just being devastated by banana bacterial wilt. So it's a bacterial infectious disease which is spreading like wildfire across the entire region. There's no way to breed conventionally in bananas a solution. There's nothing in the banana germplasm, and bananas are a hell to breed with because they don't produce seeds and pollen, so that they're clonally propagated, as you'll know. And scientists at the IITA, which is the International Institute for Tropical Agriculture, had already developed in the pipeline, using genetic modification, a transgenic banana which is resistant to banana bacterial wilt, using a gene from sweet pepper. So it's something which, people like that. Oh, it's a gene we're already eating. It's already a vegetable gene, so that's fine. And I could see the tests that they were doing in the field, where they had bananas which were just dead. They'd been devastated by this disease, and ones which were thriving and green and healthy, which were resistant to it. Those were the transgenic ones. And later, in Tanzania, I saw a similar phenomenon in cassava. You know what cassava is? Is it called cassava here, or do you call it something else? Cassava, okay. So this is big root, which is it's their real sort of fallback crop. It's drought tolerant. They huge roots under the soil, very starchy. It's something that can keep people alive essentially when the hard times come. And so every rural area, you visit every village, they've got their cassava crops in the ground. And cassava itself is being hammered by a combination of viral diseases now. Brown streak virus is the most severe of them. And I remember going to a village in eastern Tanzania where the leaves of the cassava plant were just shrunken, shriveled up. And they dug them out of the ground, and they just showed that this thing was half rotted. It was just shot through with brown. It's called brown streak for a reason. And I remember all these children congregating around, and I'm a parent of young children, and I was missing my own kids, and so I was looking at these kids, and And it struck me when I began to ask their ages that they were much smaller than they should have been. These kids were all suffering from stunting, from malnutrition. And then it dawned on me that their food security situation was absolutely perilous. They had no they had no money, the family had no money, they had no supplies of food other than the cassava, and the cassava itself was now being struck down by diseases. And I also knew, because I visited in Uganda earlier, that there was a GMO solution to the cassava virus disease in the pipeline as well. And again, I'd seen these incredibly healthy plants with flourishing, vibrant green leaves. But the thing that I remember most about that, visiting that trial in Uganda, isn't the healthy green cassava plants, it's the fence and it's the padlock, this huge padlock, which keeps the GMO in and keeps the surrounding population out. And that padlock to me was incredibly symbolic, because it illustrated the reality, which is that something which is labeled GMO cannot be used in Uganda or cannot be used in Tanzania, cannot get from the laboratory to the field trial to the farmer, and so cannot be taken to feed those hungry children. And when I looked into their eyes, and I, as a parent, realized that I had some, perhaps a small level, but I had some culpability in their situation. If I hadn't contributed to the anti-GMO hysteria, which then later enveloped the whole of the world and contributed to where we are in Africa, where these crops stay behind locked gates and they can never be taken out to farmers, then these kids might be better fed today. And so from that point on, I decided the most important thing to do is to work with farmers and with scientists and with communicators in developing countries to bring their perspectives more clearly into the debate. And that's the work that I'm doing now with the Alliance for Science at Cornell University, again supported by the Bill and Melinda Gates Foundation, which itself has some big investments in these food security crops, along with all of their other work to eliminate polio and to control malaria and so on. And I also spent a lot of time in Bangladesh. And for me, this was one of the most impactful experiences I had, because this particular GMO crop ticks all of the boxes. You know, what are the anti-GMO themes we've been told? They increase chemicals, right? Well, this BT eggplant in Bangladesh is specifically intended to reduce insecticide use. What else do GMOs do? Well, the farmers can't save the seeds. They're done by private multinationals. Well, this was done in the public sector. The technology was donated, developed by Indian and Bangladeshi scientists, and the farmers, not only do they get given the seeds for free, but they're encouraged to save the seeds themselves and to share them with neighboring farmers and within their families. What else are we told about GMOs? Oh, they're only for big farmers, only for the big agricultural monopolies, the kinds of scale operations that we're familiar with here in Nebraska. Well, in many cases that's true, but it's not true in Bangladesh. This was a GMO which was explicitly intended for the benefit of farmers who are so poor that they have an area of land which is no larger, and in many cases somewhat smaller than this hall that we're in today. And so as I looked at this, and I spoke to these farmers and I asked them what their experience had been, the thing that they told me was that they had been visited by anti-GMO activists who had told them that if they grow this crop, their children would be paralyzed, right? So if they grow a crop which improves their livelihoods, which reduces insecticide use by 80%, and by the way, do you know how these Bangladeshi farmers apply their insecticide? They're not driving tractors around. This is not a mechanized situation. They're wearing loincloths and flip-flops, and they're bare-chested by and large, and they certainly have no breathing apparatus or anything. And they go, and they spray these things around, which are carbamates, organophosphates, all sorts of the more toxic or neurotoxic insecticides that we know about. And they spray on average every 2 days. This is a tropical country. There's very high pest pressure, and the rains wash them off. So they spray up to 100, even 140 times during the growing season, not because they're stupid. These are very expensive pesticides, but they do it because otherwise they'll have no crop. It'll be infested and completely riddled with this caterpillar. So this was incredible to me that people who would call themselves environmentalists would be out there trying to stop a crop which reduces the use of insecticides. How could that happen? And I went back to Africa and I started hearing more of these myths. I was in Tanzania again, and at a workshop where I was talking to farmers in the region, one man stood up and said that he would never grow GMO crops because they would turn his children homosexual. Which is a terrible thing, of course, because these are countries which are afflicted by homophobia. And there was in neighboring Uganda, they tried to pass a homophobic law which would have not just criminalized but subjected the LBGT community to potentially the death penalty. It's incredible to understand. And so it struck me that each of these myths and these conspiracy theories attached to GMOs was somehow culturally appropriate. In where I'm from, in Europe, it's what are we all scared of? What's the big disease of aging populations where people live long and healthily? It's cancer. Cancer is what's killed my friends, and it's what kills a lot of people who live long. So GMOs cause cancer. What is it here? It's autism, right? How many times have you heard that GMOs cause autism? In Africa, people were saying to me, well, I can't have GMOs because they cause obesity. And I'm like, yes, they do cause obesity if you eat too much of them. You can see the same with gluten and with all of these different kinds of foodie myths that have gone around. And for me, this is a profound injustice that our sort of superstitions in well-fed, rich countries have been exported to the detriment of those in food insecure developing countries. And so ultimately, this is where I come back to. This isn't just about science. It's about justice. It's about righting a profound wrong which is being done to powerless people around the world. And so that's what the Cornell Alliance for Science is about. And I hope you join it, and I'd hope you join me as well in doing what we can to right what has been a profound wrong. Thank you very much. I don't have any idea how long I spoke for then, but it may be, I don't have access to any kind of timekeeping device.
Only an hour and a half.
Only an hour and a half, so we can all go to the pub now, or unless you want to have some time for questions.
Well, I think there are some folks up here that maybe have some questions. We have microphones in the aisles. Surely that generated some questions, some comments right here.
Thank you, Mark, for the wonderful talk. Fascinating. I wanted to ask you because I'm a food scientist, but I'm also a biologist, my undergraduate. So the first question that people ask me is like, so how is our food supply? Are we gonna die from GMOs? I'm like, okay, this is gonna be a long talk. But other than the evident difficulty to convey like the science behind this to like the public audience, like non-trained people, I really think that this GMO issue is a multifactorial problem. For example, there's a lack of interaction between the scientific community and the general public. There's also like intentional misinformation, as you said before. There's also a very complicated issue of like the general public to like have critical thinking and being able to self-learn about these issues. Like, no one is going to go to the peer-reviewed journals to look at this. You have to have like some training. And finally, there seems to be like a sentimentalistic thing about food and GMOs, because it's like our food, the thing that we eat every day. It's like very hard to like just look at it as like a scientific issue. So considering all this, I was wondering if you could share with us which one of these dimensions of the problem is the ones that are the ones that are contributing the most to this misconception about GMOs, and how can we as scientists help to like spread good science and good counsel, I don't know how to call it, to create a fair understanding about this? Thank you.
Wow, that's an incredible question, because you summarized a lot of different challenges there. And the thing is that the GMOs are not real. There's no such thing as a GMO which is separate to other ways that crops have been bred. Previous to the GMO, there was wide use of mutagenesis, right? Using chemicals or using gamma radiation, which causes breaks in the DNA and causes mutations, which are then selected out phenotypically, not using any idea of genomics, and then taken straight to market. And there's the ruby red grapefruit, there's durum wheat, there's multiple examples of mutagenic crops which are not only on the market and were taken out with no degree of safety testing, but not only that, but they can be labeled as organic. And rightly so, in my opinion. It really doesn't matter. It's not too difficult to check that these are okay. And yet, if you think of the process there was all sorts of potential impacts happening at the level of the organism's DNA. So if you're concerned about tampering with DNA, you should look at that before you'd look at the much more precise techniques that are conventionally labeled as GMOs. And so there was no logical basis for singling out this technology in the first place. What happened was that initially it was seen as crossing a red line, and what it really was, I think, is the transgenic aspect, the idea that a foreign gene, so that you'll hear different elements of this myth, but the proverbial fish gene going into the proverbial tomato, which I think was proposed sometime in the early 1990s, and that then got around because it taps into some very deep-seated notions about purity and species essentialism and chimeras. Remember the monsters of Greek myths, and every other culture has the same kinds of myths of different creatures that have, you've got half lion, half eagle or something. And these monsters have particular characteristics which are very scary and which are somehow transgressive of what we consider to be acceptable within nature. And these kinds of cultural notions have come up all the time in our literature. I mean, the Frankenstein story is probably the archetypal example, and that's why it was so appropriate, in fact, that they were called Frankenfoods. The idea being that humans have developed a technology which transgresses the limits of what nature had previously imposed. And the transgenic aspect of that seemed to be doing that. Now, we now know, with what we know about genetics, that that's actually not the case, and that all of us share 30% of our DNA with carrots and 97% or something with chimpanzees. And so a chimpanzee gene in a human or a carrot gene in a strawberry or in a pig or whatever doesn't have any meaning. There's no such thing as species essentialism at the level of DNA. DNA is just DNA and so on. But that isn't how people understand it. And then later, because of this initial concern and sort of disgust factor, the transgression of the sacred, if you like, GMOs then became symbolic for so many people's concerns about the food system in general. And many of these concerns are well held. I mean, absolutely there's been a problem of overuse of pesticides. There's been a reduction in the toxicity of pesticides, but I still think it's a serious problem and one with serious environmental impact. Of course, the food system in rich countries doesn't keep people as healthy as it should. And that's not because of GMOs in the food supply, it's because of the too much sugar and too high rates of consumption of red meat. So let's talk about the real things, in my view, but what happened is that the concerns that people have about big ag, about farming being corporatized, about the overuse of chemicals and so on, became identified with GMOs, and GMO became a lightning rod for something like, this is the thing we've got to eliminate, and this will somehow turn the clock back to the bucolic, romanticized Arcadia of how farming should be conducted, and how our pure food, it was called a pure food campaign initially when this started off, and you can see it with the whole organic movement. Again, it's the idea of something, the natural, the purity, counterposed against the artificial, the synthetic, the human-made. Again, these are not categories with any degree of scientific meaning. You can have, within the organics sector, you could have a synthetic pyrethroid and a natural pyrethrum pesticide, insecticide, and they're chemically pretty similar, and they'd have the same effect on the environment, but one's natural and one's artificial or synthetic, and they're treated differently on that basis. So the naturalistic fallacy is a fallacy, but it's still something which has deep resonance for so many people. Now, that was a rambling answer to what was admittedly a rambling question. And I think this is we could talk about this all night because there's so many different dimensions to this issue.
What could have caused you to change your mind 10 years earlier?
To 10 years earlier than what? Than now or than?
Then 10 years earlier than when you did change it.
What didn't?
What could have?
What could have? Oh, thank you. No, that's a very interesting question. Almost nothing. Because believe me, people tried, including scientists who I had respect for, but I just didn't believe them. I didn't trust them because what happens is that you trust people that you interact with on a regular basis, and at that point, for me, that meant the environmental movement. I'd left university to become to be an environmental activist. I'd, occupied tree houses and dug tunnels and thrown myself in front of bulldozers and set fire to buildings, and I shouldn't talk about that, and things which, and that was a very kind of a powerful experience. It's almost like being in a war, and I had such an identification with that movement and with the ideology and the sort of belief systems that had. And it wasn't really until I morphed very gradually through understanding and self-teaching on science, through wanting to talk about climate change, that I began to realize that there was a different way of looking at evidence, and that everything that Greenpeace had in a pamphlet wasn't necessarily the gospel truth. And believe me, that was a great surprise when I first saw it. And I think the phenomenon that we have of living within bubbles, political, ideological bubbles, epistemological closed loops, I think they call them in the social sciences, has become more and more profound through online media and through the polarization that we've seen in mainstream media as well. I mean, I'll come clean with you, I'm a liberal, I think you call it here. So I'm on the kind of left of the political spectrum, and I therefore have to watch MSNBC or CNN. I can't bring myself to watch Fox News because I find it physically painful. Because I disagree so profoundly and it gives me such cognitive dissonance in my head that I actually do experience that as everyone does. And so we filter our facts and we filter our evidence on the basis of our pre-existing political and ideological preferences, because that makes us feel comfortable. And that's what we all do. That's the kind of the basis of human psychology. But I think there's something about the modern world where that experience has become even more profound and become even more difficult to shake off. And this isn't in any way related to your question, but I'll ramble on about it anyway, which is that and I've been writing a book about GMOs which looks at the deeper context of this going back through the decades, that we're in what's now known as a post-truth era, right? And you can see this with and I know I shouldn't do the politics thing, right? But you can see this in the Donald Trump versus Hillary Clinton thing. Hillary Clinton loses points for being over-intellectual, i.e. for telling evidence-based truths. That's a bad thing. That makes you an automaton. That makes you a robot. Whereas if you make assertions which, in my view, are completely baseless, as Donald Trump does, then he gets points for being authentic and telling it like it is. And this is a profound current which isn't only on the political right, it's on the left as well in so many different ways as well, that we no longer seem to have value for truth, for objectivity, for there being any objective standard of evidence to which people can be held. And I think that's a kind of a zeitgeist which is so widely seen now across not just Western liberal democracies, but even more widely across the world. And I don't know what to do about it, but I think it makes the kind of the pro-science conversation that much more difficult to have. That was such a rambling answer that I've answered any potential questions you might have been about to ask, so it's probably...
I think we have another one up here.
Thank you for sharing your story and insights. You mentioned that you're involved in Cornell's Alliance for Food in conjunction with the Bill and Melinda Gates Foundation, and you stated that you hope that we'll become involved as well. However, beyond that initial zeal, what can students like myself, who are passionate about agriculture and about promoting global food security, actually do with these organizations to help out?
Thank you. It's actually Cornell Alliance for Science. allianceforscience.cornell.edu. And it depends, what you can do depends on who you are. These things are very context specific. We've worked, for example, with a group of vegans called Vegan GMO, and I just love them because it really messes with the minds of other vegans, that there's vegans out there who promote GMOs. And they get listened to. Well, they have to be listened to because they dress like vegans, they eat like vegans, and they so clearly share the values of what is quite a tightly knit community, and they do so on the basis of wanting to defend animals and improve animal welfare, and so that's what the vegans do best. And so it really depends on. We have visiting scholars at the moment. A fellows program, and we have fellows from one who's a farmers leader in Ghana. And what's he doing? Well, he wants to become empowered to become a more effective spokesperson in Ghana on behalf of the farming community, and to say, yeah, we need, it's not just about GMOs. GMOs are a tiny proportion of what needs to happen. They need mechanization, they need better access to land, to capital, and so on. They need better market information, blah, blah, blah. None of these things are specifically GMO silver bullets, but he needs to be empowered to be able to make that case. So that's what he does. And it depends on who you are, it depends on where you are, but the most important thing that people listen to is information that comes within their peer group. Things that people share with them on Facebook and on other social media. Unfortunately, it's the truth that we live in the age of Facebook science. If that Facebook science can be accurate and you can contribute to that, then great.
Mark, that was a very nice presentation, and you have a lot of years of thought. One of the things that strikes me, and I realize you weren't a scientist, you moved into science. Okay, now let's move into economics, if you will. When I look around the world and what's happening today, hasn't this kind of been so successful to be non-GMO, organic, happen partly because of the economic climate, and you look at some of the green food stores and the organic food market, and you even look at some of the major food companies that many of us work with and work for, and they're pushing their products to a great extent based on the fear, and it's a sort of catch-22. It kind of keeps going.
I was waiting for a question, but what can we do about this? That's the question, right?
Do you see that it's really kind of a self-fulfilling market strategy that's taken off based on the fears that happened 15 years ago?
Up to a point, but organic is about a lot more than non-GMO, and a lot of which has great validity. I mean, my parents are organic farmers, so I would say this, but I think the fundamental motivations behind the organic movement are genuine and are important and are valuable. I share with them the desire to reduce the inputs, agrochemicals in particular, but other inputs too. And I think the idea of seeing farming as functioning within a functional ecosystem, where you can encourage beneficial insects and try and reduce diseases based on a more sort of holistic level of understanding about the ecosystem within which farming works. I think that's an important conceptual tool which the organic movement has really brought to the fore, and which more conventional agriculture has really begun to learn from. We've seen a big movement towards no-till and towards conservation agriculture in North America, which has been ironically facilitated by not just by GMOs, but by herbicide tolerance as the trait. But that's done a major service for carbon retention in the soils, for reducing soil erosion, and for reducing also runoff. And these are agendas which I think are shared by the agroecological movement overall. we all want to see a more sustainable agriculture, and one which is able to increase productivity. And this is where organic falls down, is that there is this productivity gap, which, all other things remaining equal, mean that to produce the same amount of food, you'd have to cultivate a third more land than we currently are doing around the world. And it's difficult to conceive of how you can do that and keep the rainforest standing. So yes, organic has taught us some important lessons, but it's in an era of land scarcity and of conservation values, we're not going to be able to use organic farming to feed the world, let alone to increase the food supply that we'll need to meet the population increase, which is expected to come to 9.6, 9.7 billion by 2050. So this is why the buzzword now is sustainable intensification, to use all the different technologies and all the different approaches that we've learnt about. And I'm a big supporter of farming diversity with organic and lots of other different approaches, all interacting to seeing which ones are the best, in order to deliver this increase in food production on hopefully a reducing amount of farmland. Because remember, we're already in a biodiversity crisis where we're losing so many of the wild species around the world. The biggest threat to them is habitat loss, and the reason that happens by and large is agriculture, either through deforestation or other ways in which the habitat is lost. And so the most important thing to do is to defend and to protect large areas of land for remaining wild, or even for rewilding. You can't do that and feeding the world's population if you have low productivity agriculture. So that's an important message. We have to get a much broader conversation about conservation going, where the different trade-offs that come into play when you talk about organic versus other approaches need to be better understood. So how you get that on a label, it's taken 30 years for organic to become the byword for better or more natural or something. It's going to take a long time, I think, for a more sophisticated conversation to evolve about agriculture, but it really has to if we're going to do better for the environment.
We have another question here, and then I think we have time for one more after that.
Non-GMO labeling is something people look for while shopping in an attempt to choose healthier and or greener products. What labeling do you look for while you're shopping?
Oh, I always try and buy non-GMO salt. I really want my sodium chloride to be free from any transgenic DNA. You can buy this stuff, and I also buy organic water. But obviously the non-GMO label has no meaning, for the same reason that GMO has no meaning. What I would want to know is what the trait is. Like, if it's an insect-resistant GMO, like the eggplant in Bangladesh, then great, that's got 80% less insecticide applied to it. And in fact, that's the labeling that we've tried to promote in Bangladesh. It says insecticide-reduced brinjal. So that tells you something a lot more useful than saying GMO on it. On the other hand, if it's a herbicide-tolerant GMO, you could say, well, sorry guys, this was sprayed with glyphosate. And you might then want to try and tout the benefits of that and say, well, it was no-till as a result or something else. But I think what people need and what will help dispel some of the fear is transparency. So not scientists or authority figures saying, this is safe and you need to trust us because we're authority figures and we tell you it's safe and there's nothing to be scared of. That's guaranteed to make people even more scared. What dispels fear is the sense of power, sense of agency. Rather than feeling that you've had something imposed on you by some external agency like Monsanto who's making a profit by putting something novel into your food supply, why the hell would you ever accept that? And of course you'd be amenable to people who tell you it's unsafe and to scaremongering about it. So yes, the solution to this at the consumer trust level is a radical degree of transparency, and I'm encouraged that the legislation that's passed Congress has that included within it, or at least the potential for it, using electronic scanners, QR codes and the like, because rather than just having this black and white skull and crossbones GMO label, you'll be able to go through to a website that can tell you much deeper, more profound information, which after all conveys the meaning and has the validity of what we all need, which is a more sustainable, a more healthful, and a more productive food system.
Have you run across the use of golden rice in some of your travels?
Well, who said that? Where are you? Are they? Okay. I have not only done that, I've visited the golden rice trials which have been carried out at the International Rice Research Institute in the Philippines. I've eaten a single grain of golden rice when no one was looking, which is of course not, raw. It's a long and complicated story though, because golden rice has been in the pipeline and had a touted potential for a very long time. It was on the cover of Time magazine with its potential life-saving aspect there highlighted in the year 2000. Now here we are 16 years later with golden rice still in the development stage and not being available to help deal with this vitamin A deficiency problem, which is still a major killer of young children in developing countries. Why is that? Well, a lot of the blame has been laid at the feet of Greenpeace and other groups who have campaigned very explicitly against golden rice. But in reality, that isn't what's held it back. What's held it back is a number of technical challenges, which mean that the scientists who are developing have not yet put it forward for approval. I mean, it would be fine to blame Greenpeace if Greenpeace had stopped it being approved, but they haven't even got to that stage yet. So yes, the anti-GMO people have created an unhelpful environment within which we're all operating, but it's important to see also that there are many different ways to deal with these problems. I mean, vitamin A deficiency is being dealt with already by supplementation, and ultimately, a single solution like golden rice isn't the best one to solve it either. What will solve the problem is the same way that none of us have vitamin A deficiencies, because we have more diverse diets. And that means addressing poverty. The reason why it's important initially to deal with some of these micronutrient deficiencies is because if you as a young child, if you don't get sufficient of certain nutrients, then your brain doesn't develop properly, and that will affect your whole future life. So it's important to get in there early and to deal with these things in the best way we can and the quickest way we can. But in the longer term, of course, we have to eradicate extreme poverty, and we have to get into a situation where people have the life chances that all of us have come to expect. So yes, golden rice is a part of an answer to a more complex question, but it's by no means the end point in that journey.
Thank you very much, Mark, for a very thought-provoking presentation. Mark, to commemorate your appearance here at this podium, we have had these medals struck.
Thank you. It looks like a Nobel. It's very nice.
If you like to call it your Nobel Prize, we will be fine with that. So thank you very much.
Thank you.
And thank all of you for joining us today. Our next lecture will be on the 10th of January at 7 o'clock in this same location. Our speaker will be Mark Peschel, who is the Chief Executive Officer of the National Future Farmers of America organization and of the National FFA Foundation. So I look forward to seeing you here then. Thank you.